in the last part of chapter 4 here, we're going to take a closer look at two types of triangles that we've already defined in the very beginning. An isosceles triangle, which is a way of describing a triangle by its sides. It has two equal sides if it's isosceles. And then what follows from that is that the base angles would be equal as well. So if this is an isosceles triangle where the legs AB and BC are equal, then it follows that the base angles, angle A and angle C, would be equal as well. And if you tried the Quizlet that I posted last week, you would have gotten some practice with those properties. We call those the base angles, and we call these sides here the legs. Okay, so in an isosceles triangle, in a right triangle, we call the legs the two sides that live off of the 90-degree angle. In an isosceles triangle, the legs are the two sides that are equal to each other. And then these two angles that are equal to each other down at the bottom, we call those the base angles. Okay, it's a little bit of terminology that'll be helpful to be familiar with. An equilateral triangle by the sides just means that all three sides are equal, which also means all three angles are equal similarly. So we're going to try to apply some algebra to these isosceles triangle situations. So in the first one, let's look at what we're given and what we're looking for. I know that this angle here is 40 degrees. And then I'm looking to solve for x, right? We want to find the value of each variable. Well, if I take that 40 degrees away from the 180 that I know lives inside a triangle, we're left with 140 degrees. Okay. Now the mistake I'll often see students make is they'll say, okay, well 2x equals 140, and they try to move on and solve. What we have to do with that 140 is divide it evenly into 2, right? We need 180 degrees in this triangle total. So 40 plus 70 plus 70, there's your 140. That will give you your 180. So to solve for x here, we would say that 2x equals 70, and then we would divide by 2, and we would have x equals 35. So another thing I will see students confuse a lot of times is sides and angles. Like, well, I had somebody in class yesterday trying to set a segment length equal to an angle measure. Here I have the two legs of the triangle. I have the base angles here are equal, which means this is isosceles, which means that the legs are equal to each other. So I'm just going to write that in a truth statement here and say that 2x plus 6 equals 3x minus 6. And then this will be a pretty easy equation solve. Subtract 2x from both sides, and we have 6 equals x minus 6, and then we just add 6 to both sides. So x would equal 12 in that situation. So here we have to make a similar deduction that we made in the first one. We have to take this 90-degree angle away from 180. But again, remember, that's 90 degrees. It has to be split evenly to these two angles, which means they must both be 45. We take 90 and divide by 2 and see that each of these angles would be 45 degrees. So that's our equation solve. Pretty easy. 3x equals 45, and then we would divide both sides by 3. So x in this case would be 15. Okay, so this is interesting. We have our top angle up here. We don't know what any of the angles are, but we do know that this is isosceles. So if this base angle down here is 6x plus 6, then that means the one living next to it, it's a little tight fit, is also 6x plus 6. So the only thing that we can deduce here is that all three angles must add up to 180 degrees. It's the only way I'm going to be able to solve for x in this situation. Add up the three angles that are given and set them equal to 180 because we know that that would be true. So I'd have 14x plus 12 equals 180. So we would subtract 12 from both sides, and I have 14x equals 168. So we'll go ahead and divide both sides by 14. So x would equal 12. All right, and this is about the third time we've seen where we have the third angle, and this is exactly 90 again. So that means we have 90 degrees, really 45 for each of these. So another easy equation solve. 5x equals 45, and we would divide both sides by 5. So x equals 9. And then finally, in the last one, number 6 is very much like what we did in number 4, just maybe a little bit easier values to work with. This would also have to be x. This is isosceles. See, the legs are labeled, the legs are congruent, so the base angles are congruent. So we would have 3x plus those 2x's equals 180 degrees. Okay? So 5x equals 180, and then we're going to divide both sides of that by 5. And 180 divided by 5 is 36. So this side of our worksheet should feel pretty similar to what we had with isosceles. In fact, the equilateral, we have more to work with here because all the sides and all the angles are equal, which furthermore gives us, if all the angles are equal, we would take 180 divided by 3 and find that they're always 60 degrees. So this is even easier. So anytime I have an equilateral triangle, I know that all these angles are 60. It's going to make it so much easier to solve. Now, I'm not doing anything with angles in this situation, but these angles will all be 60. Okay, so for the first one here, right away, we can say 6x must equal 60. Okay, 6x equals 60, divide both sides by 6, and we have x equals 10. Okay? So all we're doing is solving for the variable. Now, do not say that 6x minus 5 equals 60. This is a common mistake. That's wrong. Okay, all those angles are 60, but what this is labeling a side and a side and a side. So what I can deduce here is that 6x minus 5 equals 5x. Okay, so if I subtract 6x from both sides, get a negative answer for a second there, and negative 5 equals negative 1x, which means x would equal 5, right? Divide both sides by negative 1, and x would equal 5 there. Real easy solve here. 3x just equals 60. All those angles are 60 degrees. Divide both sides by 3, so x just equals 20. So again, let's not get fooled with the 60 degrees. What the 60 degrees tells me is that this side's also equal, and then I have an equilateral triangle. But I have this side and this side, they're marked as equal, so we're just going to take that and use it. That means that 4x has to be equal to 40. Divide both sides by 4, and again we find that x equals 10. Okay. Another situation here, if this is 60 and these two sides are equal, that means we have an isosceles triangle, but furthermore it must be equilateral, right? 180 minus that 60 is 120, and that 120 has to be divided evenly because it tells me that those are congruent legs. So that means the third side here is equal to the side that's already given, so we have the ability to say that 3x plus 8 equals 4x minus 4. You can say that. Subtract 3x from both sides, and we have 8 equals 1x minus 4, and then we'll go ahead and add 4 to both sides. So we find that 12 equals x. Right? And the last one, equilateral again. So all these angles are 60. We don't have that advantage with an isosceles, so that means that 4x equals 60. Okay? This is an angle, interior angle in that equilateral triangle, so it's equal. So we divide both sides by 4, and we find that x equals 15.